Good day and welcome. I'm excited for this day's very entertaining video because we get to talk about vitamin D. Now, as a precursor, let's just take a second to remind ourselves some of the purposes of skin. The obvious no-brainer is protection. Protection from outside environmental insults. Another insult that we need protection from is temperature. So skin is very important for thermoregulation. How does it do this? Think about in a car, we've got an engine under the hood, and the engine, as it's going, it's getting hot, right? It's generating power, but it's generating a lot of heat too. Well, in the front of the car, sitting right here, just behind the grill, we got the radiator. And the radiator is simply designed to increase surface area. And we've got a pump that will pump water or coolant into the engine block to surround the engine, and that water, as it goes through the engine, cools the engine down. But then that hot water, we've got to pump back to the radiator. And the radiator, because of increased surface area and a fan beating on it and you're driving so the air's hitting it pretty hard, all of that with the increased surface area cools the coolant back down. And so now it's ready to go back to the engine and pick up more heat. Thermoregulation for the skin works in the exact same way. Here's the skin surface, and I can actually open up and regulate what are called Anastomoses. This is an artery that will bring blood closer to the surface of the skin, bypassing capillary exchange, but simply for the purpose of allowing that blood to lose heat through the skin. And so you'll notice if you're warm, you'll see veins on your hands. They're a little bit bigger. They're up on the surface of the skin. This is allowing heat to dissipate through the skin. And so thermoregulation is a really, really important job for skin. And then one thing that doesn't get enough attention as it should, a third purpose for skin, is vitamin D synthesis. As we go through this process of showing you how your body makes vitamin D, I hope you'll come to recognize vitamin D isn't something that I'm going to get a lot of in the foods that I eat. Whether I'm eating animal-based products or plant-based products, vitamin D just simply isn't one of those things that is going to be found a lot in these foodstuffs. And so our primary source is to produce it ourselves in the skin. And I want to show you how to do that. And interestingly, the key driver, the precursor for vitamin D is cholesterol, specifically a slight derivative called 7-dehydrocholesterol. And this is found in highest quantities in the epidermis, specifically in the stratum basale and the stratum spinosum. Now, let's create a timeline for how to create vitamin D from this 7-dehydrocholesterol. So starting with 7-dehydrocholesterol, we need sun exposure. And what we're really interested in is in the ultraviolet light, UVB, and that has a wavelength. We're looking about 290 nanometers up to about 315. That's the UVB that we're interested in. And that's going to take this 7-dehydrocholesterol and convert it to a pre-vitamin D3, better known as pre-cholecalciferol. Now the cholecalciferol in and of itself is not very stable, and it's going to react with body heat. Remember, we're at 37 degrees Celsius, and that body heat is going to take that pre-cholecalciferol and convert it to vitamin D3 cholecalciferol. Now, more than likely, if you supplement with vitamin D3 or you're getting vitamin D fortified whole milk, this is what you're taking into your body, this cholecalciferol. This circulates. It has a half-life of about a week, but it's not really biologically active. However, it does represent the store of vitamin D3 that I can call upon when I need vitamin D3. And the conversion of active vitamin D, and we'll talk about what regulates this, but the conversion happens in the kidney. And the signal to activate the kidney to do this is a hormone called parathyroid hormone, abbreviated PTH. And this comes from the parathyroid gland, which releases PTH in response to low blood calcium. So, we've been exposed to the sun. On a nice sunny summer day, we can get a good amount of vitamin D3 with simply 10 to 15 minutes of sun exposure. It doesn't take a lot of time. So the sun converts 7-dehydrocholesterol into pre-cholecalciferol. Your natural body heat then finishes the conversion into cholecalciferol And this is my storage form of vitamin D. And it's circulating in the blood. It'll be there for about a week, but it's not super active. When the body senses low blood calcium, that signals the parathyroid gland to release parathyroid hormone. The parathyroid hormone acts on the kidney, and the kidney will take that vitamin D3, the cholecalciferol, and convert it to an active form of vitamin D called calcitriol. Also known as 1,25-dihydroxycholecalciferol, this is what we would consider active vitamin D. Now, the biggest difference is that this active form of vitamin D has a shorter half-life, a half-life of only a few hours. And while we'll detail this out more when we talk about the endocrine system, I think it's worth noting what active vitamin D is actually going to do and why we care about it. Remember, the trigger for parathyroid hormone to be released from the parathyroid gland was low blood calcium. And so that's one of the key jobs of vitamin D, not the only job, but one of the key jobs of vitamin D is to regulate blood calcium. And we're going to do this in a couple of ways. We're going to target the gut, and here this is going to allow us to increase calcium absorption from the food that we eat. This is why a lot of times if you're trying to supplement with calcium, it will say calcium plus vitamin D, because in order to get calcium into the body, vitamin D is required. The other target is going to be back onto the kidney. And here we're going to see an increase in calcium reabsorption. Let's not dump calcium into the urine. Let's reabsorb it back into the body. And the third target we want to talk about is bone. The bone represents a huge reservoir of calcium. And active vitamin D will increase osteoclast activity, and this will break bone down to liberate that calcium so that my blood calcium can increase. So let's zoom out and take a look at what we've got. We start with 7-dehydrocholesterol. This is converted by UVB, emitted from the sun, into pre-cholecalciferol, which is then quickly converted to vitamin D3 cholecalciferol. Cholecalciferol will circulate in the blood for about a week, and in the presence of parathyroid hormone, which is released from the parathyroid gland in response to low blood calcium, the kidney will take that cholecalciferol and convert it to calcitriol. This is my active form of vitamin D. It's got a short half-life, but while it's active, there are three primary targets. Both the gut and the kidney to increase calcium absorption and calcium reabsorption, respectively, and also the bone to increase osteoclast activity to break bone down so that I can increase blood calcium. Now, clinically, there's a couple of things that I think are super relevant. Number one, vitamin D does a lot more than just regulate calcium. It's super important for the immune system. And we don't detail that here, but I just want you to know vitamin D is important for the immune system, among lots of other things. Vitamin D deficiency will clinically manifest primarily in the form of rickets. Rickets is the inability to form the hard mineral cement that strengthens bones. So with rickets, we see decreased bone strength. Now, what might this look like? Instead of being average height and strength, rickets will inhibit growth, causing the individual to be shorter, and it's very characteristic of bowed legs. That's what we're looking at right here. These legs are bowed because they don't have the strength they're lacking from the lack of calcium. Now, it is important to recognize we tend to see rickets in low-income communities that are in the northernmost parts of this country. Why the northernmost parts? Well, remember, it's the sunshine that's the primary key to generating vitamin D. And the further north I go, the less sunshine I get annually. The darker it is, especially during the winter months, right? Now, individuals with dark skin will even be at a greater disadvantage because the dark skin is absorbing UVB. That's what it's designed to do, to protect against the sun's rays. But that's also inhibiting my ability to make vitamin D. And so individuals from African American descent are much more likely or at a much higher risk for rickets than Caucasians, simply because they need more sunlight to make the vitamin D. Another clinical manifestation would be something like osteoporosis. Also associated with decreased bone strength, this is brittle bones in older individuals, typically postmenopausal women. And this has to do with this pathway here. We recognize that if we are deficient in calcium intake, then the body will rob the calcium from the bones in order to maintain blood calcium levels. Primarily because the heart is so dependent on calcium. I'd rather keep the heart pumping today than worry about bone strength. But over time, if I continue to be calcium deficient based on my diet, I might not even know that my bone strength is down. But I fall down, I break my hip, my mobility is gone, and 6 months later I'm going to die. Because of the inability to heal from this, because of brittle bones, all because I wasn't eating enough calcium. Now, why does it affect postmenopausal women? Well, estrogen and other hormones play a significant role in females in regulating this process. And with decreased estrogen levels after menopause, their ability to absorb calcium from the gut decreases. And if they don't make the necessary adjustments to increase calcium in their diet, they're at a higher risk.